corresponds. Has time been fooling us all along? Look around you. Everything appears to move. The sun rises. The seasons change. Children become adults. Mountains slowly erode. Stars are born and eventually die. From the moment we are born, time seems to flow in only one direction, forward. It feels so natural that we rarely stop to ask the most important question: what is time? Is it something real, flowing through the universe like an invisible river? Or is it simply the way our minds organize reality? For thousands of years, humanity believed time was absolute. Ancient civilizations measured it using the movement of the sun, the moon, and the stars. The Egyptians built monuments aligned with the heavens. The Maya created astonishingly precise calendars. The Greeks debated whether time itself was eternal or merely a obstacle of change. Then, centuries later, Isaac Newton proposed an idea that shaped science for generations. According to Newton, time existed independently of everything else, a perfect cosmic clock ticking at exactly the same rate everywhere in the universe. Whether you stood on Earth or traveled among the stars, time was thought to be the same. It was elegant, simple, and for more than 200 years it seemed unquestionably true. But there was one problem. Nature kept refusing to behave that way. Light, the fastest thing in the universe, always traveled at exactly the same speed, no matter who measured it, no matter how fast they were moving. This shouldn't have been possible. If Newton's view of time were correct, something about the universe didn't make sense. Then, in 1905, a young patent clerk named Albert Einstein proposed an idea so extraordinary that it would forever change humanity's understanding of reality. He suggested something almost impossible to imagine. Perhaps time doesn't flow equally for everyone. Perhaps time itself can stretch, slow down, even bend. And if that were true, then the clock on your wrist would not always agree with the clock somewhere else in the universe. At first, the idea sounded absurd, but over the following decades, experiment after experiment confirmed Einstein's prediction. Time was not the rigid cosmic ruler we once imagined. It was something far stranger, something flexible, something woven together with space itself. And if time can change, then another question emerges, one that has fascinated scientists, philosophers, and dreamers for generations. If time isn't fixed, what exactly are we moving through? To be continued. The day Einstein broke time. Imagine that you board a spaceship. Not just any spaceship, but one capable of traveling at nearly the speed of light. You wave goodbye to Earth. Days become weeks. Weeks become months. Eventually, you return home. But something impossible has happened. Your friends are now old. Some are gone. Entire generations have passed, while for you, only a few years have gone by. It sounds like science fiction. Yet according to modern physics, it is entirely possible. This strange phenomenon is known as time dilation, and it was first predicted by Albert Einstein. In 1905, Einstein published the theory of special relativity. It challenged one of humanity's oldest assumptions. Time does not pass at the same rate for everyone. Instead, the passage of time depends on motion. The faster you travel, the slower your clock ticks, compared to someone standing still. But motion isn't the only thing that changes time. Gravity does as well. 10 years later, Einstein introduced general relativity. He proposed something extraordinary. Gravity is not simply a force pulling objects together. It is the curvature of space and time itself. Imagine placing a heavy bowling ball on a stretched rubber sheet. The surface bends. Smaller objects roll toward it, not because they are being pulled, but because the surface beneath them has changed. Our universe behaves in a remarkably similar way. Massive stars, planets, and galaxies bend the fabric of space-time. And where gravity becomes stronger, time slows down. The closer you are to an extremely massive object, the more slowly time passes. This isn't speculation. Scientists have measured it. Atomic clocks placed at different altitudes tick at slightly different rates. A clock on a mountain runs just a tiny bit faster than one at sea level. The difference is incredibly small, but it is real. Every single day, the Global Positioning System, or GPS, depends on this discovery. The satellites orbiting Earth experience weaker gravity and move at tremendous speeds. Their clocks drift differently from clocks on the ground. Without constant corrections based on Einstein's equations, GPS errors would grow by several kilometers every single day. Your smartphone would quickly become useless for navigation. Every time you open a map, you are relying on the fact that time itself does not flow equally everywhere. Then there are black holes, the most extreme objects known in the universe. Their gravity is so immense that time slows dramatically nearby. Imagine standing safely far away, watching an astronaut approach the edge of a black hole. To you, their movements would appear slower and slower, until they almost seem frozen in time. From the astronaut's perspective, however, their own clock continues ticking normally. Each observer experiences reality differently. Neither is wrong. Both are correct within their own frame of reference. This extraordinary idea inspired films like Interstellar. But unlike many science fiction stories, its most famous scenes were built upon genuine physics. Near the fictional black hole Gargantua, hours passed for the astronauts, while decades passed for people back on Earth. It was dramatic, emotional, and remarkably consistent with Einstein's theory. By the early 21st century, time was no longer viewed as a universal clock. It had become something flexible, something shaped by speed, gravity, and the structure of the universe itself. But this discovery leads to an even deeper mystery. If time can slow down, stretch, and flow differently for different observers, then perhaps the past, the present, and the future are not as separate as they seem. To be continued. Does the future already exist? For most of us, time feels simple. The past is gone. The present is happening now. The future has not yet arrived. It seems obvious, almost undeniable. But modern physics suggests reality may be far stranger. If time flows differently for different observers, then one question becomes unavoidable. Is there really such a thing as a universal now? According to Einstein's theory, the answer appears to be no. Events that seem simultaneous to one observer may occur at different moments for another. The universe does not provide a single cosmic clock telling every observer what now means. Some physicists have taken this idea to its astonishing conclusion. It is called the block universe. Imagine the universe not as a movie being created frame by frame, but as an entire film reel already complete. Every frame exists, the beginning, the middle, the ending. From our perspective, we experience the frames one after another, but perhaps the universe itself contains them all at once. If this idea is correct, the past, the present, and the future are equally real. We simply experience them in sequence. It is one of the most fascinating and controversial ideas in modern physics. Yet another mystery remains. If all moments exist, why do we only remember the past? The answer may lie in something called entropy. Entropy measures the number of possible arrangements within a system. Over time, disorder tends to increase. A glass can fall and shatter into countless pieces. But the shattered pieces never spontaneously leap back together. Not because time forbids it, but because such an event is unimaginably unlikely. This increasing disorder creates what scientists call the arrow of time. It gives the universe its apparent direction, forward, always forward. But on the smallest scales, inside the strange world of quantum mechanics, many of the fundamental equations do not care which direction time flows. They work almost equally well forward or backward. This has led physicists to ask an extraordinary question. Is the flow of time a fundamental feature of reality, or is it an emergent property arising from deeper physical laws that we do not yet fully understand? No one knows. And perhaps that is what makes time so extraordinary. It governs every heartbeat, every memory, every civilization, every star. Yet, we still struggle to define what it actually is. St. Augustine once wrote, "If no one asks me what time is, I know. If I wish to explain it, I do not." More than 16 centuries later, his words remain remarkably relevant. We can measure time with astonishing precision. Atomic clocks lose less than a second over millions of years. We can predict how time changes near black holes or aboard satellites. But understanding what time truly is remains one of science's greatest mysteries. Perhaps time is not a river carrying us toward the future. Perhaps it is the landscape through which the universe already exists. Or perhaps our minds create the sensation of flowing through it, one moment at a time. Whatever the answer may be, every memory you've ever cherished, every dream you've ever imagined, every civilization that has ever risen, and every star that has ever shined exists only because time allows change. And maybe the greatest question is not, what is time? Perhaps the greater question is, without time, could anything truly exist at all? Because until we answer that question, the greatest illusion of the universe may still be ticking all around us.